Hello everyone. Today I would like to have a lesson called Introduction to Human-Computer Interaction, from buttons to AI partners. So today's lesson I'll go to have a walkthrough with you to how to design an AI product with AI tools and how compare the current product and compare what's the difference between the interface design with AI assistant design. And also we are going to answer the question, at least here, how can we design intelligent products that people can understand, control, trust, and enjoy using? Okay, let's start it. So this is today's learning objectives. Explain why human-computer interaction is more than interface design. Second, understand basic concepts such as usability, user experience, feedback, mapping, cognitive loading, and error recovery. Third, describe the basic process of user research, prototyping, and usability testing. Fourth, explain how artificial intelligence changes the way people interact with computers. Fifth, identify common interaction problems with AI-powered products. Last one, understand the importance of human-centered AI design and tell you what's the difference with human-centered design and non-human-centered design. Let's start it with open questions. Is HCI mainly talking about placing buttons and windows and everything, or about how people and machine work together? So let's see the slides. I listed the different methodology from the very beginning of paradigm of HCI to the current one. The first is CLI, Command Line Interface. Maybe some of you familiar with that, because from very early age, if you want to interact with the computer, you have to remember lots of complex commands, really heavy loading on recognition loading. And this is friendly. The command line interfaces is friendly to the computer, but not friendly to the people. That's why only experts can use that, not for beginners. And then, because the GUI, which is a graphical user interface developed, on the screen of the computer, they start to develop the buttons, just use the metaphor of the real life buttons and checkboxes, and the process bar, and mouse cursors, mouse pointers, and also the windows. That's why Windows, the name Windows for operating system, the name comes from. And then the touch screen become more popular. So people doesn't have to use the mouse and the keyboard. Actually, from my point of view, mouse and keyboards are not really intuitive for the beginners, because the mouse, when you move mouse, there's a mouse in the moved on the platform, which is 2D platform, and it is not overlapped with the screen space. And for the touch screen, so people just click or just touch wherever you want, and also you can slide down, slide up to the UI views, such as browsers, such as Windows. Very intuitive operation. And then the voice interface came out, and the people can talk directly their intention to the system, and the system will know what you are going to do, and then drive the AI agents or the workflows to whatever you want. This is mainly This interface mainly use vocal signals, vocal commands with user, and the user speakers to play the synthetic voice to the player to implement the interaction. And then generative AI come out, and the system can generate whatever you want, the images, the texts, the commands, and tell you the the contents that system doesn't pre-programmed. So in the past, all the results is pre-programmed by the programmers. But with generative AI, the output will be unpredictable, which is based on statistics. And there's a good way and there's a good and bad. The good thing is you can generate unlimited results, but the bad thing is you have to control the quality of the result. And then maybe in the future, or maybe right now, some people work in a really advanced area, and you can talk to a robot. Robot will make action to the commands, like do the housework for you, or do some labor work. The robot is also called an interface. So in the academia area, there's a dedicated research field called HRI, which is the human-robot interaction. So back to the main topic, what is human-computer interaction? The study and design of how people interact with computers, digital systems, and intelligent technologies, the way of people how to interact with and how to use the computer, or and also how computer give the feedback to the human. The whole circle is called HCI, the human-computer interaction. There are 4 very important components in the HCI. The first one is people. So we're mainly concerned about the people's abilities, people's habits, the talking habits or the living habits, and also people emotions, whether people are happy or not happy, and people expectations. And when people send a task to the system, what's their expect for the system, and also people's limitations. And it's talking about people's, because we're human, we forgot things. Memory is one of our limitations. The second component is technology. I'm talking about the computers, the smartphones, the robots, the AI models, wearable devices, and the interactive environments. For some of those concepts, it's very easy to understand, but the interactive environment, some people said, hey, what's that, right? And interactable environments means also some people say that's also a term like ambient computing. So the computer will be everywhere with in your environment. When you live in your environment, you can interact with computers. The computer is actually immersed into embedded into the environment, so you can interact with. The third component is tasks. So what the system will do. System will do searching, system will do learning, communicating, creating, deciding, or solving the problems. So this is the behavior of the systems. The last thing is the context. Context means what's your context of your interaction happens. For example, if you stay at home, right? If you stay at the school, if you work at the office, you got sick, you go to hospital. When you're driving, you are in the vehicle. And if you are in the public space, because sometimes in public space we don't talk about the privacy, or the virtual environment. If you are on the Mars, right, it's virtual environment. You have to let a system understand where you are, what the context you are at. So HCI asks questions. How do people use digital products? How do people understand system behavior? How do systems better understand human intentions? How can technology become more usable, safe, and enjoyable? So in a word, HCI studies the relationship between people, technology, task, and the environments. So why is the HCI important? That's a good question. Technical capacity alone does not create a successful product. So the product, if the product is successful or not, is not depends on the software or hardware it advanced. It depends on how the design is made by the designers. So there's two systems, the system A and system B. We can see the system A have powerful features, list everything on the website, and so that they have complicated manuals, the unclear feedbacks, and high learning costs. We don't know what we do when you open this web page. But if if we see the system B, we see the fewer features and the clear workflow, easy to understand and easy to recover from mistakes. You can see there's a very clean UI design, the study poll, and there's only two paths for the exams. Basic algebra and the shift from production possibility curve, and select teachers. That's it. So again, software is success not because how advanced the program, the software and hardware. It depends on how well the HCI design. Users usually prefer system B because they can understand it, because it is well designed, it is clean, the color is a very fine-tuned color, and also can help people complete the goals, and also can help people recover the errors, from the errors. If some people make mistakes, and so does AIs. If mistakes, how does you recover from the mistakes? And also make users feel in control, not go to a different way, and because AI also have a hallucination problem, not let user think the AI will take away of the control, and just build a confidence to let user use AI products, and also trust the result. And the AI make a hallucination, but there's a way to reduce that. And if you don't have confidence, if AI doesn't have confidence to the results, just tell the truth. Maybe just tell the truth to the user. That'll be better to make up the truth. Right? So in summary of this slide, advanced system that nobody can use may have almost no practical value. If you have practical value, and the system will be used by somebody. A brief history of human-computer interaction, from an early age to a very advanced currents, and a little bit in the future. Each stage reduced how much people had to adapt to machines. So in the future, the machine will adapt to the human, not human adapt to the machine. The first phase is command line. I mentioned before. You have to type the exact comments. You don't have any typo. You don't have to. It's not allowed to have any typo, and it is very efficient for experts. The experts will remember lots of commands. How many actually for experts? If you remember lots of commands, you are experts. If you remember less, you are not experts. This is old school way, and which is difficult for beginners, because you have to remember, you have to know the commands, also the parameters. There's the parameters come behind the commands. You have to try out 1, 2, 3 and know how to interact with the system. So this is command line. The second phase is a graphical user interface, which have windows, icons, menus, and pointers. We use WAMP for short of this kind of paradigm. The actions, we use the WAMP for this kind of paradigm. Actions become visible and learnable because people can see directly what you're going to act with. The buttons, the slide bars, the web pages, and people can directly click on the menu elements. Although they're using mouse, like I mentioned before, the mouse and screen are not on the same platform, but still, if you're used to that, and people will be very efficient to interact with these elements. The third phase is the touch and the mobile. The gesture means your body gestures, as well as means your finger gestures, like multiple fingers. If you use MacBook, you're very familiar with that. Multiple finger interaction, and also sensors. If you tilt the phone like that, you have feedbacks on the screen. And always available computing enter the daily life. We mentioned the computer is not always like computer with screen and the case, computer case. It's not like that. Right now, the computer is everywhere. Your mobile phone is computer, your earphone is computer, and your wristband, smartwatch is all of those devices are computer right now. The last phase is natural and intelligent. So we interact with computer by the voice command. We can we directly talk to the computer, and the computer will understand our vision through the gaze tracking, and also on human body we have wearable devices, and we have generative AI and robots. Users can express their goal directly with natural languages, and system can understand what's your intention. Even your intention is not completed. Computers will become more collaborative rather than a passive tool. The history of the ACI is a history of asking people to adapt less to the computers, and the computer will adapt more to the people. So what does make the interaction good? So we evaluate a system. It's good to do good interaction or bad interaction. We have to evaluate the usefulness, the usability, experience, and AI-specific tasks. What is the usefulness? Does the system solve a real problem? How do we use the system? Right? Example, does an AI course recommender actually help students to choose suitable courses, or let the students choose the course that they don't need, or is not suitable for their background? Second, and usability. Can users complete tasks easily and efficiently? Learnability, task success, efficiency, error rate, and recovery is all the elements we should to evaluate the system is good or not good. Because we don't want the system to spend like 1 day, 2 days to complete their tasks. That's a too long time for the users. This is usability. Third, user experience. How does the system make the users feel? Users feel comfortable, enjoyable, trustworthy, or frustrating, confusing, or stressful. Right? If you feed the first three elements of the system will be evaluated as good interaction. Otherwise, it's bad interaction. There are additional criteria for the AI system when we evaluate it. Can the answer be verified? So how do you trust the answer from the AI? Does the AI communicate uncertainty? Yes, AI make hallucinations, but does the AI honest to tell you they have an uncertainty? Can users correct and undo? Right, because some of the AI agents they do the task very quick, but some of them make mistakes. Can you undo the tasks? That's a main feature for the AI agents. You have to make sure all the tasks finished as you want. It's personal information being protected. You don't want to leak your privacy information, your health information, your background information to the cloud and leak to the internet everywhere because AI have the agency to distribute your information not under your supervised. They are going to publish something you don't want to publish. For example, the API keys. I made a mistake before. I accidentally uh, exposed the API key on the Google Cloud, and Google Cloud gave me a warning for that. I didn't pay extra bills. Yeah, that's my luck. But I still got warning and paused my cloud service for 1 month. I couldn't use that for 1 month. Okay, the last one. Our users become overly dependent. Designing for human abilities and limitations. As I said before, we are human, we made mistakes, and we also have limitations. People are not computers. Attention, memory, perception, and judgment are limited. Attention is limited. Users do not read everything. If you give a very complex layout of the website, and the people will lose their tracking, lose their focus, will just go to next page maybe, and your list of the information will be useless for the if you have too complex layout over there. And design implications. Highlight important information. If you want important pop-up important information shows to the user, you highlight it. You make a different color, or you reduce the area of useless elements, and reduce the visual noise. What's a visual noise? Visual noise is when you see the website, there's unrelated elements on the website or useless elements on site. It is a visual noise. Avoid competing elements. Yeah, there's if you want to tell the users this story, that story, but there's elements competing with that idea or elements you want to show to the users. You have to avoid that and use a clear hierarchy. If you have a hierarchy elements on the layout, you have to use a clear one. Title 1, Title 2, Title 3, and Title 1, Title 2, Title 3, such like that. Working memory is limited. People cannot just hold a large amount of information at once. People forget things. The system have to help people to recognize the new information other than recall the memories. The first design implementation is help people recognize the information you want to provide to the users over recall the memory from the user's head. Yeah, because when you're recalling, users is not really want to do that. Yeah, and also you have to if you have different steps to guide the user to implement some tasks, you have to show the recent actions, like last action, like last action you did before, and what's the action you're going to do next, and provide examples like some AI assistant like Doubao, and they provide examples like how to generate a red pack cover or something, and how to generate the photos, interesting photos, like photo templates or something. And last thing is avoid memorize commands. You don't want user to memorize too much commands. You have to design system to let user use their intention to connect the commands in the system. That'll be more friendly to the user. That's the thing. People form mental models. What I mean. For example, when people say a trash can means deleting, right? And people say the magnifying glasses means search, something like that. So user infer how system work from prior experiences. So for risk is, if the AI give you the fluent results, it means correct, because AI really confident to output the results. Then user feels it's correct, but sometimes not correct. And also user may think AI understand everything because AI trained by the different knowledges and different subjects, but actually not. AI not understand everything. And also user may think AI remembers everything, but actually also not. AI forget things because there's a context window. If there's a knowledge outside of context window, AI will forget. And also AI has human intentions. People said, hey, AI is just like a human and talk naturally to the user, but AI actually doesn't have human intentions. AI imitating the human intentions. So AI products should clearly communicate capabilities, limitations, data use, confidence, and what the user should verify. 5 fundamental interaction design principles. Good interfaces take actions visible, understandable, consistent, and recoverable. There are 5 principles I'm going to introduce one by one. The first one is visibility. Users should see what actions are available. The functions should not hide into the complex hierarchy in the menus. So users should see directly what action they will take. Second, feedback. The system should respond after every meaningful actions. For example, if you upload a file, system will tell you the file uploading is completed. If you press a button, the button will change the color. That's very simple. And if you send a mail, after the mail sent, you'll get a message from the mailbox. Third one, consistency. Similar actions should produce similar results. So if the system have a similar task, similar action, you have to use similar design for the buttons, for the checkbox in every pages. Same gesture should not use the different actions or different appearance for the buttons. Fourth, natural mapping. The relationship between the action and result should feel intuitive. For example, the volume slide bar, if you move left to right, it means the volume will go higher. Fifth, error prevention and recovery. Prevents mistakes and support confirmation, autosave, undo, and clear errors, which means if you delete a file, before that you have the message to tell you if you delete it or not. And also you can autosave your document while you're editing, and also undo the error actions you took before. For AI design, if you design AI product, review what the system is doing, what information it uses, what assumption it takes, what is uncertain, and what the user gonna do next. Traditional software versus AI systems, and interaction shifts from the selecting functions to expression intentions. So for traditional softwares, all the software behavior are regulated, is programmed. But for the AI systems, user express the intention and system interprets reasons, explains, recommends, and acts. You can see the different dimension of the traditional software and AI systems. Input, traditional software is structured input, so there's a regulation for the input. And for AI system, the input will be no matter text input or voice input or multimodal input, which is vague or conversational. The output for traditional software relatively predictable. For AI system, it's probabilistic, which is not predictable. Repeatability for traditional software is same input, same result. For AI systems, same input may vary, and output also may vary. Capability boundary for the traditional software is clearly defined, but for the AI systems, it's difficult to understand. Errors for traditional software often reproducible. For AI systems may appear inconsistently. User role for traditional software chooses functions. For the AI system to express the intentions. So you don't have to choose the functions one by one. You just express to the system what task you want to finish. System behavior. Traditional software follows the programmed rules. If there's an action that is not defined, not predefined by the programmer or the product manager, will be not triggered. So all the rules has to be programmed. For the AI system, it generates, infers, recommends, or acts. Even for some behavior which has not been defined, AI system can also correctly respond. So there comes new challenges. The intention expression. So you have to let user to express their intention. The tasks, you have to analyze the intention from the user. And AI system can proactively tell the user when the task is finished, or decide which notification has to let user know or provide some more extra information. And AI system can also be autonomy. AI system can run by itself. And AI system also have uncertainty, evidence, and responsibility. AI is not just another button. So some people think add a chatbot to the old workflow can change the traditional software into an AI product, which is big mistake. This is big wrong. So we can start from the traditional presentation workflow. We all make PPTs, right? What are you gonna do to make a PPT? Make a PPT slide. The first one, you have to create a file, right? And select a template, write the content, insert images, adjust the layout, and review the slides. That's a traditional pipeline workflow for the presentation slides. But if you use an AI-supported workflow, the first thing you find a good AI product like Gemini or the Codex. First, describe the goal and audience, and set up the background information, and generate an outline. Then refine the structure, and also you can let the AI to adjust the structure. Then generate the draft content. Then generate the visual suggestions. You can change the visual designs rather than choose a template. You can partially change the design. And then review, edit, and approve. If you don't agree with any slides of the your presentation, you can just edit. So if you design this AI presentation maker products, there are some design requirements. You have to let the user to express their intentions, and also can properly analyze the intentions, and also have to let user iterative correction. Yeah, if the user not satisfied for a slide, they can change, modify, and redo it, and do it again. And also, you have to let user know what AI is doing, and you have to preserve the human control, which is called human in the loop. And also, you have to keep the visual version comparison, and you have to provide function, the undo function and history function, and you have to separate suggestions from confirmed actions. So AI is not just to help user to click buttons. AI is to help user to reshape their idea and understand their intentions and finish the task. Now we are talking about the input modality, from the GUI to LUI to multimodal interaction. So we have the GUI, graphical user interface, the LUI, which is the language user interface, and the multimodal input, which is different the model of the input, such as text and voice and the videos, etc. We start from the GUIs. GUI means buttons, right? The menus, the icons, the windows, and the touch gestures. The advantages of the GUIs are the the actions is visible, so you can directly see the menu or see the buttons, which means visually the GUI elements are visually intuitive, and also functions are discoverable, so you can easily find the functions through the different category of the menu. For example, the file menu, you have to the functions will put it related to the file processing. You put the file menu. Functions related to the view function you put into the view menu. And also results are predictable because everything is pre-programmed. You can easily control the result. But limitation is too many steps for complex tasks. For example, if you use a Photoshop or you use ERP software, if you want to finish a complex task like a background remove, right? If you have a translucent textures like hair and like thin clothes, if you remove the background, it will be complex, and you have to use multiple steps. You have to remember the steps, and if you meet a new case, you have to adjust your steps. Second limitations: if you design the complex actions, your menu, your navigation will be more complex. The second modality is LUI, the natural language interaction through text or speech. The text also kind of a part of the language. And the advantages of that is user can express complex goals. Like I want to make a timer for today for my laundry. If they finish, tell me when, and give me a good alarm of that, something like that. Second, it supports open-ended tasks. For example, if there's a task no certain results, the language user interface can also support that. Third, low manual learning cost. So you don't have to learn where the menu is, where the button is. You just make a voice or text command. That's it. System will help you to find out where the menu is. But there are limitations. The user may not know what to ask. For example, if you have an experience to talk to AI assistant, at the very beginning, the AI will tell you what you're gonna do. Otherwise, the user never know what they are going to talk to you to AI assist. Ambiguity and misunderstanding, because language are ambiguous and easy to make system misunderstanding. For example, if you make a voice command such as just like give me that thing, system will never know what's the thing. System will do the act on it. Third limitation is the unreliable output. So task will be maybe the output is not the user expected because language ambiguity or the task is uncertainty. Multimodal combines text, speech, images, video, gestures, gaze, touch, and sensors. So practical direction, the user can use language to express the goals, then use a graphical interface to inspect, modify, confirm, and control results. So multimodal is the overall phase for the interaction. So system can understand the input from the user natural language, even where you're looking at and what you're talking about and your touch gestures all together to understand the user behavior and what user's intention to analyze the task they're going to take. 4 core problems in AI interaction. The goal is to appropriate control and appropriately calibrated trust. The first problem is the controllability. So user can decide what allow to that AI do. So that means user can decide what AI's behavior and what AI's boundary. So if you design the product, you have to have different designs, such as stop function, stop button. If you see the evidence that AI goes to wrong direction, you have to press the stop button. And also undo button. If you got the result which is not your expected, you have to redo the action to let AI do that again. And also permissions. You can let the AI should ask for a permission, such as read and write your file on local machine, and also ask your permission to submit your personal information into cloud or something like that. It's also about confirmation. The AI should confirm with you before the AI takes the action. And adjustable autonomy. So for the autonomy, the AI has to have different level to execute different actions. And the AI has to let user preview before the action. So user can know beforehand the action being taken. Second, explainability. Can users understand why the AI produced the results? Explainability not means AI has to show all the internal process like foundation models or something like that. Instead, AI will show you what the data or what the information is used, what the assumptions it made, where the answer comes from, which parts are uncertain. Third, predictability. Can user form reasonable expectations? The AI should behave consistently in terms of consistent tone, capabilities, permissions, response formats, and safety boundaries. Fourth, trust calibration. The goal is not to maximum the trust. Users should trust the reliable outputs and also pay attention to the output because the system may be wrong. There's a little discussion. Which is better, a confidence wrong AI or an AI that clearly communicates uncertainty? Think about it. The human-centered design process. When we design an AI product, we always start from the people and the problems, not just start from the desire to add an AI. First of all, we have to understand the users. Who are the users? What the users goal? What's the context when users use the AI? And what's the difficulties if a user using AI, and what the difficulties they're facing to the problems, and what the existing tools they're using for current. Second, define the problem. When you start an AI product, You will never start from I'm going to build an AI product. Instead, we are going to analyze the problem that a specific user group struggles with a specific task in a specific context for a specific reason. Third, generate ideas. Possible solution may include interface changes. Well, maybe you have to change the traditional software from clients, or make new recommendations, or add chatbot, or maybe introduce the multimodal AI or automation. If you identify the problem can be automated, you can introduce automation to the clients, or human AI collaboration. AI is one possible solution, not always the only solution. First, build a prototype. You always start from the low-cost prototypes, such as paper sketches, wireframes, clickable mockups, storyboards, simulated AI without all MVPs, which means you start from the low cost, you can iterate fast, you can rapidly develop your prototype and let user know what you're going to do and evaluate your ideas. Fifth, test and iterate. When you design an AI product, you have to observe how the user use the product, and improve the design based on evidence. You have to validate the problem before building the system. Test interaction before investing in a larger model. Now, this slide is designed for how do we study users. So we have to understand users, then we can design the good AI products. Use multiple methods here because what users say, what users do, and what user needs are not always the same. There's a different methods. We start from the interviews. So interviews used to understand what's the experience the user have, what's the motivations the user have, what's the user needs, what's the user facing the frustrations. It's best for user why they have to adopt this AI technology. Second, observation. For the designer, you have to watch users in real environment, discover unspoken problems, because in some environments, in some interviews, users cannot tell you the real problem. You have to observe by yourself during the real environment. Surveys. You can collect information from many participants, but for how many people, how many users facing this problem. And then you will know how many users will adopt your AI product. Behavioral data, clicks, completion time, paths, which means users' behavior in the software, and abundance tasks, repeated actions, why the user repeat that action, and errors, what errors that user face. This is the best way to understand what users will do. Usability testing. Ask participants to complete specific tasks while researchers observe. So you can observe on your side to understand the specific tasks being executed by the user. AI can transcribe, organize notes, identify themes, summarize feedback, generate research questions, and assist the qualitative coding, but it cannot replace real users. Remember that. It cannot replace real users. Usability testing. Do not just ask, do you like it? Right. You have to observe the realistic behavior of the users instead of relying only on polite or hypothetical opinions. So if you ask questions such as, do you like this product? This is the weak questions. Or do you think the design is good or bad? These are the weak questions as well. And would you use this system? Or is this interface easy to use? These are weak questions. You don't get too many information from the user. So you have to design the good questions for usability testing. Better task. Use this AI learning assistant to identify a suitable course for next semester and explain why it is appropriate. Observe where users begin, what they enter, how they interpret the response, whether they verify it, and how they recover from the mistakes. In this way, you can better understand how the user behave in your software, and you can, based on that, you design a good user experience. Basic usability metrics: the task success rate, the completion time. You have to record the completion time for specific tasks, or number of errors. You have to report the errors that users made, and help requests. If some user cannot finish the task, they will ask for help. Satisfaction. User will satisfy. Did user satisfy the system? And learnability. Or you can add additional AI metrics, such as did user notice incorrect information? Did they over rely on the AI? Could they identify the sources? Could they revise the output? Did AI reduce the workload? Did user remain in control? Yeah, you can add these questions to user in the usability test, and it depends on the intention of your test. Let's expand this slide into the future of HCI. The design object is expanding from the interface to intelligent behavior and human AI teamwork. The first direction is a passive tool. It will change the passive tools into proactive assistants. When should the system act, and when should it remain silent? You don't want to, if you focus on something, you don't want your phone ringing or your system proactively tell you the notification. No, you don't want that. You have to design a system that properly tell the information to you. The second direction is change from single interactions into long-term collaboration. So which means how should the system memory your characteristic or the informations that you have, and also remain the privacy on your side, and user control be managed. You can let users control and let users know what AI is doing under the hood. The third direction is change from screens into physical environments. Right now, the user interact with the computer mainly from the screens, but in the future, right now user interact with system mainly from the screens. But in the future, user may interact with system with smart glasses, the cars, the homes, the wearable devices such as the smartwatches, and robots and the public spaces. Fourth direction is change from individual tool to human AI teams, which means they can enable the human by the AI agents, multiple specialized agents gather, analyze, create, check, and support human decisions. The fifth direction is change from the interface design into AI behavior design, which means what role of the AI can play, what permission of AI can have, when it should take initiative, how should they handle uncertainty, how it should involve a correction, when it should involve a human. Summary. There are 5 ideas you can remember from this introduction. The first one, HCI studies relationships among people, technology, tasks, and environments. or you can say context. Second, the good products are useful, usable, understandable, and trustworthy. Third, design must be consider attention, memory, habits, expectations, and limitations. Fourth, AI as language generation, predictions, and autonomy, but also introduce uncertainty, bias, hallucination, privacy risk, and responsibility. How does your AI product handle these disadvantages and advantages? Fifth, the central principle of AI product design remains human-centered design. Future engineers should not only take AI more intelligent, they must also make it understandable, controllable, trustworthy, and effective as a human partner, which means the AI should always collaborate with human, not replace the human. Thank you very much.